So the talk I'm going to give today, I'm going to be very quick because I know we have other presenters. I'm going to be talking about parameterizing prompts, and I'm going to kind of go into detail about what that means. So I just wanted to start off with like a pretty famous tweet by Andrej Karpathy, who's one of the co-founders of OpenAI, and also I think AI director at Tesla, built their whole self-driving technology. And he made this like very viral tweet that English is the hottest new programming language. And he's partially right. Like with the advent of like these prompting-based models, like we can use English to sort of express like our desires and have the model basically figure out the rest and produce some sort of artifact, whether it be text or images, to our desires. So the kind of the rough equality here is that prompting is now like basically AI programming. But and when we develop a prompt, I don't know if many of you have, it's a very iterative process. Usually the first time you try and have one of these models, one of these prompt-based models, try and give you some desired output, you never get it the first try. It's always like an iterative process. And usually the very abstract workflow people go through is you have some problem that a prompt-based model can solve. You iterate on the prompt until you get some solution that like fits your specific use case, and you use it. But there's like two defining like ways you can use it. Sometimes you use a prompt and you use it once, and then you immediately throw it out and you never use it again. But the other case, which is like a little more valuable, is being able to use it many times. So, and the main like technique or the main piece that we use to automate it is using parameterization. I'm going to get into what that means. So, automating prompts, you almost always you want to parameterize it. So what I mean by prompt parameterization is letting software inject data into your prompts. If you're familiar with HTML templating and injecting variables on like a WordPress website, it's very similar except with your prompts, your big blob of text, you're inputting some data that you want the model to infer on, whether it be like a YouTube comment saying like the YouTube comment sentiment. You don't know what the YouTube comment's going to be, but you can have a piece of code, inject it into your prompt before you send it to one of the LLMs to give it back, to give a response back. And the main kind of use case that like that many people have heard of, retrieval augmented generation, RAG, sort of the abstraction of RAG is doing this parameterization. RAG, one key piece is parameterizing a prompt via queries from a knowledge database. Okay, I'm going to show like a few different code examples and just kind of show like incrementally like how from like basic parameterization to getting like slightly more advanced. The first example, our problem statement that I'm going to like show for you is classifying customer support tickets. Just going to make up a fictitious scenario that we need to use LLMs to classify a customer support ticket as like a P0, P1, P2, P3 as like priority of when they get to need, of how fast they need to be resolved. And we're going to use an LLM to solve this. And the normal like way we would normally solve this is you would copy paste everything that's in the support ticket, paste it into ChatGPT, the likes, put a little bit of extra directions like I have here, like describing what a priority level is, saying the title, the author, the body, and then we have ChatGPT give us a response. And I'm not going to go through the response, just want to get the basic idea. The next level is using parameterization, where the main difference between the first picture and the second picture is at the very bottom, title, author, and body, I've replaced with this little ticket.title, ticket.author, and ticket.body. The whole point being is we're going to have some external software inject that information into our prompt. And this is basically like level 1. And most of the time, this can like solve exactly what you need. But almost always, as you solve a problem, suddenly complexity likes to come in through the door and sneak its way in into your problem. So if I'm going to add like an additional like constraint is oftentimes I'm going to come up with another fictitious scenario. Let's say your customer support ticket framework, there's now suddenly premium users that need to be treated differently, and your prompt needs to do a totally different behavior with the premium user. What you might do is you might do a little bit of like an if statement in there to try and say, okay, if it's a premium user, here's another extra string that you need to put in. Oh, if it's this special user, make sure to use this priority level. and like, oh, I forgot to use that, I forgot to give the model extra direction down below. And by adding this if statement, we've kind of like bifurcated our model to saying like, oh, if a user's premium or not, we now need to keep in our heads like 2 separate prompts effectively. And it can kind of get gnarly. Like I've built applications like pretty poorly with this approach. It works, but pretty poorly with this approach of doing many, many if statements. You have to sort of contextualize and keep in your head like 7 different behaviors of your prompt, and it's almost always like a really like difficult thing to wrap your head around. And so kind of like the big lesson is like at the beginning when I'm mentioning that like English is the hottest new programming language, it may be the AI programming language, but that doesn't mean it's good. English is not like the best thing to program in, but it's extremely expressive. It's basically it's a complete trade-off. And some personal like patterns for parameterizing prompts. If you use like Google AI Studio or you have your own parameterizing solution in a custom application, kind of like the 4 big things that I've noticed that I think you should use it because it's helped me. I believe it can help you too. Is 1 is avoid branching behavior. Like I had with premium and non-premium, we've created these 2 separate prompts that change the behavior. They're like kind of going back to an old software engineering principle of single responsibility principle. Should have 1 prompt do 1 very explicit thing. Because if you have a bunch of if statements that are branching of behavior, keeping all of that behavior changes in your head and like what flags are on and what's off, what state is my prompt in at this point, you're asking for a whole spaghetti ball mess. The second is making things human readable. To me, having an if statement in there isn't really the most readable thing. I think I think like one thing that's worked for me extremely well is making it as human readable as possible. I should be able to read it like a book and not have to like reason about logic in my head too much. Another thing is separating things into logical blocks. So when you use a parameter, you should try and like keep it local to a certain section of the prompt. Again, for organizational purposes, it's good for the head. And the last thing, which is I think obvious, but I think is always good to reiterate, is keeping it simple, stupid. Just make sure like you have a prompt that does 1 thing and 1 thing extremely well. A bonus thing I want to mention before I hand off the stage is image prompting. So there's a game that I've been working on the side that it's going to be a Guess Who clone for people who've played Guess Who. I'm calling it Who Dis. And I've been using this fun image prompting approach that I wanted to share where the problem statement for those who haven't played Guess Who before. Guess Who is a game where you have an array of people or some sort of items, and each of them like have a bunch of different attributes about them. So maybe people with like long hair versus like short hair or blonde or brunette, and you and your opponent both see the same thing. You each have a secret person that is one of these collection of people, and you have to ask questions back and forth, yes and no, to guess who their hidden character is. And I wanted to be able to like make this game, but using AI generated images because I thought it would be fun. So I was using prompt parameterization in order to generate this collection of people, but varying individually specific attributes about them. So if you can see in the prompt, like over here, like when I say appearance, appearance is going to be its own special category. It's going to be an enumerable, saying like scary, cute, tiny, something like this. And the idea is I can just randomly choose a bunch of different attributes, compile an image prompt for the model, and then have an image representation of a data structure. And if you sample about like 30 of these, you can get a bunch of monsters together, and then you can make a game. You can make a Guess Who game out of this. And it doesn't stop at monsters. You can make a separate collection for people, realistic people, and get something like this. And you can even do it like anime characters or whatever you want. And it all kind of boils down to this approach of like taking a data structure and then finding a way to compile to a string via this parameterization. And I think this is a really cool approach that you should all consider if you're ever interested in making a Guess Who game. And if you want to see a demo of this like after and make your own category or something, you can talk to me after. Maybe we can make our own. That was pretty much it. yeah, I'm on the internet. That's all my links. And yeah, thank you all for listening.